Hello everyone, let's start with the next question that says k top elements in an array. And let me tell you, this is same as the question. K most frequent elements in an array, right? Now let's suppose we have been given an array with any numbers 1, 2, 3, 2, 2, 4, 5, and 4, 2, 3. Makes perfect sense. Now let's go with approach 1. Approach 1 that simply comes to your mind when you hear about the K top elements is that it has something to do with frequency. When you think you have to, because how many times an element occurred is its frequency. Now, if I know it has to do with something with frequency, I can either go with frequency array or an hash map. Correct? Now, if this was the case of a map, what will we have here? We will have element and then element pointing to its frequency. So the first element is 1. Okay, frequency is 1. Then as you go ahead, 2. Frequency 1, 3, 1, 2, 2, 2, 4, 1, 5, 1, 4, 2, 2, 4, 3, 2. Right. So now you know you have you have an element and a corresponding frequency. Now what is the need? You have to sort all the frequencies of the corresponding elements in a way that you can return k top elements. Right? K top elements are the k most frequent elements. Now if you do the sorting, what will happen? You will do sorting on the basis of frequency. So you will know that this is the most frequent element, right? And now 3 and 4, there is tie. Let's say k is given as 2. 3 and 4, there is tie. What will you choose? This will be a constraint that will be given to you in the question that, okay, if two elements have the same frequency, then return the larger element. So what will be returned? 4. This is given the constraint. Given the string. I hope this is clear. And then this is k of, this is your two most frequent elements or the two top elements of the array. Now, if you think about its time complexity, traversing through this array to create this hash map took what? Time complexity of linear time complexity. And then we did sorting. Best case time complexity for sorting is n log n. So what is your complexity? Big O of n log n. I hope this is clear with everybody. Now, let's go to the better approach. How do you know that you have to go to the better approach or there is something that you can do it better? Now, when it is, I told you, just remember, you will have top, closest, largest, smallest, words like these. And along with it, if you've been given the value of k, then you have to once think about what? Heaps. You have to think about heaps. K top element. That means K most frequent elements. That means K elements that exist most. Given this, we have to create this hash map because hash map is something that we create after we know that the question deals with frequency. Now comes to the part that is K and that is top, right? So now first question is to decide which heap to use, right? This, let us say this is my heap. I don't know which heap. This could be max or min heap. Which heap I have to check now, right? So let's come to this. Now the heap size is k. And this time we need what? K top. We need K most frequent. That is, the frequency of them is maximum. So we want the elements whose frequency is maximum to stay back in heap, right? Because we need K elements. So if whatever are the elements, we need these many elements here to be what? The maximum frequency elements. Now let's say one's frequency is 1. So we started with 1, comma 1. How are we putting it? Frequency element. Why? Because we want sorting to be done on the basis of frequency. Then why are we keeping element? Because we have to return the top k elements, right? So 1 and 1. Okay, no issues. Then we come upon second. Second is what? 4 and 2. Okay. Then what? 2 and 3. Okay. Now the size of the heap is 2. Currently the size of the heap has increased its maximum permissible size. So we have to pop one element. Now which element to pop is the question. Since we need to keep the maximum elements in the heap, we need to retain the maximum frequency elements, k maximum frequency elements actually, inside the heap. So what are we going to pop out? Right, that is the question. So we will pop out 1, comma 1 because the frequency is 1. Coming to the next thing. Then you have next. It goes by 2, comma 4. Now what we have to pop out? Now this depends on the constraint. Okay. We took the constraint that we need to keep the maximum. So what are we going to keep? What are we going to give it out? 2, comma 3. Right? Because if first thing, what happens in general comparator, if your first element, the element on which sorting is done, right? So frequency is the element on which sorting will be done. Let's assume two of the heap elements have the first element, respective first elements same. So what will be the sorting now be done on? It will be done on the second element. Got it? Okay. Then we get in the next element that says 1, comma 5. Now what will go out? 1, comma 5. So now what we have to return? We have to return a vector that contains what? That contains the leftover elements of the heap. And what will be the leftover elements? The leftover elements will always be k elements given that the array size is greater than k. So what will be returned first? Since it is which heap? It is min heap. Now why is it a min heap? Because we want to keep the maximum elements inside the heap. And when it is min heap, what is the top element? The minimum element. So we'll just pop out all the min elements so that what we have in the heap are relatively max elements. Got it? Next. Then what do we, if next we pop out, what do we get? We get 2, comma 4. What are we going to return? 4. In 4, comma 2, sorry, we're going to return 4, sorry. So what will be the first thing that you get? 2, comma 4, right? What will you return? 4, then 2. Make sense? Makes sense. This is what we have to do. And then what will be the complexity for this? Since it's a heap, every insertion deletion operation goes by log of k. So time complexity in this case goes by n log k, while we have this O of n here as well. And this is for creating the hash map, frequency array or hash map, whatever you create, you have to iterate through your given array once, right? Okay, let's see the code part. So let me just 1, 2, 3, 2, 2, 4, 5. Anything I'm taking, okay. And then I'll take 20. Okay, so let's code for this. What are we going to k top elements, right? So we have to return a vector that contains k elements. Vector int k top. Okay. What have we been given? Vector int array, and we have been given int of k. Make sense? Makes sense. Now we have to first create a map int, comma, int. We don't need an ordered map for this case. So we can write an ordered map. Everybody clear? Because unordered map has a relatively lesser time complexity, the average time complexity I'm talking about as compared to your map. So we don't have a particular, case for map. So we'll just take unordered map because anyhow we have to use it. So coming to unordered map, and then what you will do, you will traverse over your, this is your given vector. You will traverse over it. Right? And what will you do? What will you do? If MP has that element, you're going to increase its size, increase its value. MP array I plus plus. Now you have mash a non-ordered map created with where each element corresponds to its further frequency. Now what we have to do? Now we have to create which heap? Which heap? Now we have to create min heap. Why min heap? So that we can retain the maximum frequency elements. What is your min heap? That you write it like this. Oh, sorry. How do you write min heap? You write it priority queue. Not a good idea to write it here. Okay. So you write it, and this is not the part of the code. Okay, this is what I'm telling you only. You write it this way. Priority queue int vector int greater int and the name. Let's say min name. Okay. So now we don't have an int. We have a pair of frequency and element. How do you write a pair? You write pair in this way. Int comma int. Now what you have to do, you have to replace all these ints with this. How will you do that? Priority queue. You know, the best when you're doing this so that you do not miss any angular brackets is you write this first, then you double click on this int so that the int path gets, highlighted, and then you replace this with this part. Otherwise, there are chances you may eat or you may add some extra angular braces. Or you may eat some vector keyword or something with the other thing. There are chances of, going wrong in here. Right? This closes here, this closes here, and this one closes here. And you have min heap. So what now in the min heap? In the min heap now, what? How do you traverse over a map? For auto IT MP, right? What do you have to do? Min heap dot push. How do you have to push it? MP dot second and then MP dot first. Why second? Because your second is frequency and your first is element, right? Perfect. After you've pushed to min heap, if min heap size gets greater than k, what will you do in that case? You will, mhm, you will do min heap dot pop, right? Post this, you have elements left, right? So post this, let me write here, okay? So what do we have? While. Now we only have k elements left in the heap, right? So what will we do? While min heap is not empty. What to do then? We have to define a vector which we are going to return. So you remember here, we are returning a vector. And this vector we are creating right now. So vector answer. What will you do? Answer dot pushback. What? Min heap dot top dot what? Min heap stop. Min heap stop has what? Frequency element dot second. Got it? Because this is what we need. Many of the times people get confused, but there are no, there are no braces against second. And after this is done, what do? You do min heap dot pop. That's it. And then you return your answer. With this, you end your entire function. Everybody good with this? Great, that's it. So this is done in log K. There is another better method to do this, but since it's a heaps playlist, I'm not going to discuss it right now, but we'll do that question as and when we go to that. It is basically an implementation of bucket sort, right? So we'll do that, but not now because right now is the heaps playlist. So yeah, thank you so much. You'll find the code of this question. If you couldn't, follow up with the code and you want your time to go through the code, you'll find the code in the GitHub repository. Link is attached already in the description. You'll also find a G form in the description if you want me to take any concept, any question, anything you want me to help you with, or you want me to give any feedback. Please use that G form. And yeah, thank you so much. Thank you. Bye-bye.